Okay, in this video we're finding the derivative of this function, and the way we're going to do that is we're going to use the chain rule. So we use the chain rule. Now, how does the chain rule work? Well, I'm going to show a few steps here, maybe more than I need. But the idea is that you have a composition of functions. One of these functions is y equals e to the u, where u is this piece up there. U is equal to tan theta. That's what u is. And then what we do is we find the derivative of each of those functions, and then we multiply together. The derivative of e to the u is e to the u. The derivative of tangent theta is secant squared theta. Now, maybe I should just write that as a little reminder, as a formula. And when I write that formula, I'll use the variable x. d dx of tan x is equal to secant squared x. Although we have proved that in class, that at this point is memorizing or looking it up, but hopefully memorizing. Sort of what it means to know calculus. You're supposed to know those formulas. And then what happens then, if we're trying to find the derivative of y with respect to theta, is we multiply these two derivatives. Notice the first one's the derivative of y with respect to u. All right, that turned out to be e to the u. And then the next one was the derivative with respect to of u with respect to theta. So the first is the derivative of y with respect to u. The second is the derivative of u with respect to theta. And we multiply those together to find the derivative of y with respect to theta. It looks like two fractions where there's cancellation, even though that's not really what's happening at all, but maybe a little bit. But that's another topic. Okay, so I multiply those together, and notice now I have variables u and theta. Well, I want to go back and replace u by tan theta. That gives the answer, but it seems sort of long, and I think it can turn people off to the whole process because there's so much notation that's brought in there. Usually, I don't think people will solve the problem that way either. So usually we'll do something more quick, which is we won't write down, explicitly this y equals e to the u. Let's just look at it this way where we go a little faster. Y prime is equal to, okay, how am I going to find y prime? The way I do that is I mentally ignore that u part. I've now highlighted it with a dark color so I can't even really see it very well. And I look at e to the u and take the derivative. Well, the derivative of e to the u is e to the u. All right? So e to the u, the derivative is e to the u, and I replace that u by tangent theta at that point. Then I multiply by the derivative of tan theta, that's u, and that's secant squared theta. So once I understand what's going on, how this chain rule works, it's clearly goes way faster than writing all the steps out on the right-hand side with all that notation, which I think could, possibly, trip people up anyway, doing all that. So that's our answer. By the way, I also have this other formula that I'm using. I almost feel like I don't need to write it down because it's such a something we use so often, but the derivative with respect to x of e to dx is e to dx. So we have that also as a formula that I'm using in this problem. But look how quick this is if once I know what I'm doing with the chain rule. I don't have to show all these things. It made it, the way I'm explaining it looks like it's a really long problem to do, but it's actually, really quick. All right, so that finishes that video. Goodbye.